All right, now we're going to take a look at the next example, which is a little bit different because now you can see that in the expression here is no longer, there's a coefficient in front of the x, and that's the only difference now. And so there is a trick to see, where the midpoint will be at, but we're going to go ahead and solve it algebraically, and I'll explain that afterwards. Okay, so our first step, and looking at our last steps, we talked about number one, isolating the absolute value expression. So isolate the absolute value expression. Okay, so that's our first step. So make sure you write that down. So what I'm referring to is this right here. Okay, A minus B. All right, so make sure you isolate that. Okay, so now what we're going to do is we're going to add 10 to both sides. And this is really important, is that you have to isolate this before you set up your two cases. So now we have our absolute value equation, and the absolute value expression has been isolated. And now what we can do is set up our two cases. Okay, so the first one is 3x plus 9 equals 6. And the second one is 3x plus 9 equals a negative 6. Because remember, that's the distance of 6 units to the right. That would tell you 6 units to the left. So we're going to go ahead and solve for this. So I got 3x is equal to negative 3, divide 3 to both sides, and we get x is equal to a negative 1. Great, we have one solution. Let's go ahead and check the other one. I'm write or here because it's or. All right, then we have 3x plus 9 equals negative 6. So I'm going to subtract 9 to both sides of the equation, and we get 3x equals a negative 15 divided by 3, and I get x equals a negative 5. So our two solutions are negative 5 and negative 1. All right, so you're probably wondering, well, Ms. Fawn, how do you figure out what's the middle point? So I'm going to show you a trick here. So earlier we talked about, for the last example, was the absolute value of x minus 4 is equal to 6. For example, this one, technically that's just 4 units to the right of where 0 is at. Okay, so this one I'm gonna use a highlighter so that you guys can visually see what I'm talking about. So you always start at 0. I'm gonna use a highlighter, if I can find a highlighter, just so you can visually see this. You don't have to write this down, but maybe take notes for yourself. But this is just an add-in piece to figure out, well, what is my midpoint? We know midpoint is negative 3, right? Or the middle of the two solutions, negative 3. But let's figure out how we got to that negative 3. So we're going to start at 0, and I'm going to follow this expression here. So because that's positive, I have to go 9 units to the left. So I'm going to go 9 units to the left, which is right here. Okay, then that x here, we're going to divide it by 3. And when I have negative 9 divided by 3, it's going to take me back to negative 3. And so that's just a quick preview on how absolute value equations are transformed. We are going to later on look at graphs of absolute value expressions, and we're going to be looking at how it transforms through transformations. But right now, let's concentrate on solving the equation. At least you have an idea of how that works.